Today we are going to start a unit on sequences and series. A set of numbers written in a given order is a sequence. Each number in the sequence is called a term. And a special sequence where the previous term defines or determines what the next term is going to be is called a recursive sequence. Write the first three terms of each sequence. So it's asking you to find the first term, the second term, and the third term. The first one says an equals n. Well, to represent the first term, we say a1. Notice that n is equal to 1. So what I'm going to do is wherever I see an n in the problem, I'm going to put a1. So it's just 1. Now a2 will equal 2. And a3 will equal 3. Another example here. An, we'll call it a1. Wherever I see an n, I'm going to put a 1. So it's going to be 2 times 1 plus 3, which is 5. A2 is going to be 2 times 2 plus 3 is 4 and 3 is 7. And a3 is going to be 2 times 3 plus 3, which is 9. And that's it. I want you guys to try later to do that problem right there. And again, all you're doing is replacing the n with a 1, 2, and 3. The next part says write an algebraic expression that represents the sequence. Then find the ninth term of the sequence. So this is going backwards from what the previous part did. This time I give you the sequence and I ask you to come up with the formula. So the easy way to look at this is to say that the first term is equal to 2, the second term is equal to 4, the third term is equal to 6, and the fourth term is equal to 8. You have to ask yourself, what is one way to get from 1 to 2? Maybe you say add 1. So let's see if that pattern works. Now with the 2, can you just add 1 to get to 4? The answer is no. So adding 1 is not working for the pattern. Maybe you say multiply by 2. So I'm going to take 1 times 2 to equal 2. 2 times 2 equals 4. 3 times 2 equals 6. And 4 times 2 equals 8. So that is working for this sequence. The way we're going to say multiply by 2 is that an equals 2 times n. It also says find the ninth term of the sequence. Well, to find the ninth term, all you do is plug a 9 in for n. So 2 times 9, which is 18. Let's look at the next one. We have 12, 6, 4, and 3. So again, I'm going to start writing it out. My first term is 12. My second term is 6. My third term is 4. And my fourth term is 3. Now you ask yourself, how do you get from 1 to 12? Maybe you say add 11. Can you do 2 plus 11 to get to 6? And the answer is no. Okay, maybe you say multiply by 12. 1 times 12 is 12. 2 times 12 is not 6. So that's not working. Okay. What you could do, maybe you say, ooh, I see it. Take 12 and divide by 1, you get 12. 12 divided by 2, 6. 12 divided by 3, 4. 12 divided by 4, 3. So you just have to take 12 and divide by the n value. The way we say that is that an is equal to 12 divided by n. And to find the ninth term, we take 12 and divide by 9, which I will reduce that fraction. It is 4/3. Let's look at our next example. This one's a little more difficult. Our first term is -1. Our second term is 2. Our third term is -3. And our fourth term is 4. Well, what I do notice, besides positive and negatives, it's just an n. 1 and 1, 2 and 2, 3 and 3, 4 and 4. However, my odd ends do have a negative answer, and my even ends have a positive answer. So when that happens, where it's going positive, negative, positive, negative, positive, negative, you will start out as AN equals -1 to the nth power. And in this case, times n, because you just get the same number back. Test to make sure it works. -1 to the first is -1 times 1 is -1. -1 squared is 1 times n, which is a 2, equals 2. So this is working out. These types of problems do take a little bit of time to get used to. We will try more of them in class tomorrow. Now this next piece, it says write the first 3 terms of each recursive sequence. Recursive sequences are also difficult to do. Alright, it tells us that the first term is equal to 5 and it gives us a formula. We want to find the second and the third term. Now if you look at this problem, I would ask you, is n or n minus 1 bigger? Hopefully you would say n is bigger. So call that your bigger term. Call it A2. So now, if n equals 2, what does n minus 1 equal? Well, if n equals 2, n minus 1 equals 1 plus 1. So if you look at this A2 formula, it says take the first term and add 1. Well, our first term is 5 plus 1 equals 6. We do need to find the first 3 terms, so to find the third term, what you do is call the n your bigger term, so call that 3. Now, if n equals 3, n minus 1 will now equal 2. This says take the second term and add 1. So it's going to be 6 plus 1, which is 7. And that's it for that problem. Let's look at the second problem here. The third term is 25, and I tell you that an plus 1 is equal to 2.5 an. We want to find the first 3 terms. So it gives me the third term. I need to find the second and the first term. Okay, my question for you is n plus 1 or n bigger? Well, n plus 1 is bigger. So you're going to call that your A3. Now, if n plus 1 is equal to 3, what would n equal? Well, n equals 2. Well, this says take 2.5, or it says A3, which will be 25, should be 2.5 times A2. And to solve for A2, you would divide by 2.5. You get A2 equals 10. Now to get A1, you're going to call the n plus 1 a 2 this time. Therefore, the an will be A1. A2 is 10 equals 2.5 A1. Divide by 2.5. And you'll get A1 is equal to 4. You guys should have room left. I'm going to have you guys try that one as part of the do now as well. And it says Sherry wants to increase her vocab. On Monday, she learned the meaning of 4 words. Every day that week, she increased the number of words she learned by 2. Write the sequence she learned for that week. Well, the sequence she learned, she started out with 4 words. If she increased by 2 words the next day, she went to 6 words. And then the next day, 8 words, 10, 12, 14, and 16. And we're going to stop there because that's 7 days in a week. Write a recursive definition for this sequence. So if you look, it says, you could probably tell you take the previous number and add 2. Well, the way we can say that as a recursive sequence in mathematical terms as opposed to words is an will equal the previous term, which is an minus 1, plus 2 more. You do need to say what your first term is equal to, where the first term equals 4. At this point, you can try the 2 skip problems that we did skip, and we will talk about it more tomorrow. To look at this,